Now let's look at how atoms are put together, because you need to have a good picture of this when we start talking about detecting radiation. An atom has a nucleus, and this nucleus is surrounded by the same number of electrons as there are protons in the nucleus. Let's look. This is not the picture you thought you'd see, I'll bet. These are pictures taken by Voyager, looking back as it's leaving our solar system. Notice how dim the sun is and how closely the inner planets are clustered around the sun. NASA also has this diagram to explain what it is we're looking at. There seems to be mostly nothing there, and gosh knows that's true. It's sobering to look at how little mass there is in our solar system and how brilliant the NASA folks have to be to even find these specks of planets in the vastness of space. How about an atom? Well, let's look at a gold atom. Gold's pretty heavy, right? The density of all nuclei is roughly 2.3 times 10 to the 17th kilograms per cubic meter, meaning most of the atom is empty. On the other hand, the next gold nucleus is on the order of 6 miles away, depending on the bonding, which is very different from how stars are laid out. Neutrons show that this emptiness in atoms is true. Think about how often you would have to shoot a laser beam at random into the solar system to finally hit the sun. The mean path for a neutron is often over 10 centimeters, and for aluminum it's 72 centimeters. How many atoms did the neutron go through? Let's use aluminum because its atomic mass is 27 and its density is 2.7 grams per cubic centimeter, and that makes the math easy. How many atoms are there in a line along 72 centimeters? Well, let's see. 1 cubic centimeter weighs 2.7 grams, therefore it contains 1/10 of a mole. This 1 cubic centimeter then contains 6.022 times 10 to the 22nd aluminum atoms. This means each aluminum atom occupies 1.66 times 10 to the minus 23rd cubic centimeters. Let's let the atoms be contained inside of cubes, so the diameter of a single aluminum atom is the cube root of this number, or 2.55 times 10 to the minus 8th. If we lined all these atoms up, then a neutron would pass through 3.92 times 10 to the 7th atoms per centimeter, or about 2.8 billion atoms in 72 centimeters. A neutron, on average, goes through 28 billion atoms before it collides with a nucleus. Now do you believe that atoms are mostly nothing? Why don't we fall through the earth? Or why can't we walk through the walls? That has to do with the electrons and the Coulombic forces, which is a story for later. Let's go build the universe, proton by proton.